Hey everyone, Greg Thiessen here. Today I want to talk about quoting. I'm going to show you how XMD will give you fast part layouts for easier, more informed tool and mold estimates. With this, the layout will already be set up for your DFM feasibility study whenever needed, and when kicked off, the design already is launched and ensure it will match the quote with the knowledge automatically captured. It's the best way to communicate intent from estimating to the designer and ensure that nothing is lost. All right, let's get into it. I'm going to show you on a part I selected for today that is actually not ideal for demo. So we're going to start with our XPM like we always do. This is a 2-cavity tool, and we're going to key in 9,000 shrink. If you don't have shrink for estimating, which often you might not, you can leave it at 0. That's no problem at all. They can key that shrink in later when they start the design or when they start designing with your same file, and it'll automatically scale it for you. We're going to select these 2 cavities together in part data. You can import any file type you want, and in this case the customer sent CATIA. These are real world parts, by the way. So this is an actual job that we built here at Synergetic. So it's doing some calculations. It's going to grab the other part. And if you've watched the Expert Part Manager video already, this is all going to be very familiar to you. So the XPM is laying the parts out with a rough spacing, and now we will define the parts and finalize all that. So XMD or XPM already sees what the part data is, so we can simply accept it. I'm going to change the background to black just so you can see this a little bit easier in the video. So yes, that is the part data. All I have to do is say yes. XMD automatically places the tip point for you, so we'll accept through that. Now we've got to set up the die draw. In this case, the customer did send die draw lines. And if we roll the part around, we can see there's going to be a boss over here. That'll be down in the core. So the part will be orientated like this. We'll pick the base of that die draw line. It's actually a compound line. And XMD puts that part now into die draw. And since we've set up this part, it's going to automatically set the next part up the exact same way. We won't have to pick that again. So I'm going to select the seal off lines, so I can select and deselect the things that are not lines if that's the way I choose. So I'm going to take these action vectors off. We'll get them next. And now it is action vectors. And we don't have any part ID, grain, runners. You can key in another name and put any kind of data in here that you want. I'm just going to say keep these little buttons and clip tower. All right, second part. Again, I'll change it to black. Already selected the part data. Already has the tip point established, and already has the die draw established equal to the first part, so we don't have to repeat ourselves. XMD is just doing a little bit of processing on that, and if I roll around, you can see that that's, go to view 5, you can see the die draw actually matches the die draw line. We'll accept through that. We're going to pick the seal off lines, deselect the action vectors and the solids. It wouldn't change anything if you left them selected. We're just getting the file organized. Action vectors as supplied from the customer. You're free to draw on your own even at this point. We'll accept through. We'll say keep the rest of the data. So now what XPM has done is it's orientated the parts. We worked with it to establish the die draw. It's looking for one of the action lines, and it's making that action line square to the tool automatically. Often that's what we would strive for in tool making. In this case, we probably would want these larger actions square to the tool, so it'll just be a quick change. We're just going to rotate these parts to what looks a little bit more appropriate, and we'll move them around quickly manually. Now this is what I was talking about in the beginning when I picked parts that were not really ideal for a demo, but what they are ideal for is to show you a real world situation. So often, and probably 90% of parts that you're working with that are like a 90-degree rotation into die draw, this orientation and all of this will be automatic. You won't even have to adjust anything. It works so well. But there are these cases that, of course, we want to tweak. We want to make them a better layout, less steel, that sort of thing. So we'll quickly edit that now. Simply right-click on one of the parts in the Expert Part Manager window here. Use Dynamic Move. We're going to set it to group so it actually applies the same translations to both parts. We'll rotate those parts so that they're square to the tool, and actually bringing the large actions actually square to the tool. We're going to change that tip point location. And that looks a lot better. Reposition parts is turned on. So a final quick look at this before we actually start the tool and put some plates around this. So looking at the actions, we know we're going to have a slide over here. We're going to have a large slide underneath here, pulling all the way along the part. And we'll do something like a hook slide in this inner area. All right, simply start mold. So you can easily adjust the plate sizes as you see fit. First, what we're going to do is we're going to go to the parting line editor. Since this job is being quoted and it's not modeled yet, we'll go to the parting line editor and do a quick little edit to the size of the main blocks. Turn it black so it's easier for you to see. Okay, so let's add a bit of steel up here. We know we've got those cavity hook slides, so we need some extra steel there. And we're going to have a large slide in this job in the core side. So let's go about 8 3/8. And then the overall, we've got a little slide on the one end. So we're going to want 6-7 inches over there. Let's see what 34 inches does. That looks pretty good. Go to the other view, section B. Yeah, almost 8 inches for that big slide. That should do it. All right, so we'll say OK to that. Now that we've got our main block sizes established, you can change the steel type. We're going to change the clamp plate sizes. When you change the cavity side, the core automatically updates as well. Let's make them thicker on this job too. I'd say ejector stroke looks about right. Maybe the rails should be a little bit wider. And if you notice, for each of the plates in the main blocks, it actually gives the weight. So you can apply your shop rate to the different steel types for your estimate. When you're satisfied, hit OK. And it's going to populate all the plate sizes, all the assembly. Obviously, you already seen the parts were orientated correctly. We've established all that. It's a quick tool for the estimator to run through to have the parts actually orientated and laid out in a mold. They can see the steel around it rather than just a sketch, or rather than just numbers in a spreadsheet or in a program somewhere. And the layout is already ready for your feasibility department or your mold designer to get started. All of this information is going to be captured on what the intent of the layout was, which is sometimes hard to see in drawings or sketches. It's just a better way to do it. Now with XMD, the bill of material is always populated. This can be exported, either the whole thing or just the plates, if that's all that's being estimated at this time. So you'll have this if you want to utilize it. Also, you can check the parts a little bit more if you want to. So let's take a look in view 1. We'll do a draft check. So when you're doing a draft check, you can actually mouse over and it'll give you the exact draft angle at any position. So as the surface changes. So we can see this is all in draw. This is core side that's red. We know we're pulling this with a slide. So it's a great visual for the estimator, and definitely the perfect tools for the feasibility department. Everything you would need: draft check, mass and volume of the part, wall thickness, all the tools that you need are here. And there we are. So if you have any questions, please comment, and until next time, see ya.